ఫోన్ ఇదేనా? ఇదేనా ఫోనా? సరే ఫోనా?
ఒకసారి సరిపోలా మనుషులు పనికిరారు
అది కూడా అంతేరా. అంటే మనుషులు ఎక్కువ చేయాలా?
వస్తువులే మనుషులు
వస్తువులు కాదురా, నీకు తినకుండా నీ ఊరికి ఎట్ట పడతారు బట్టల? చెప్పు నాకు.
నేను ఇప్పుడే బట్టలు ఇంటి బట్టలు
ఏంటి ఇది పెట్టుకోరా,
హలో ఇయ్యాలా
Yeah, good morning, everyone. We will start the class in a couple of minutes. Okay.
ఏం మైదా ఒళ్ళంతా పడుతుంది కాపు లేదనగా
ఆపలు
అది ఏం అవుతాయి
ల్యాండ్ కాస్తుంది
కింద పడింది కాదు నువ్వు మరి అక్కడ లైట్గా ఆపలేదమ్మా
లైట్గా చేస్తారా పై పై చేస్తాను
Okay, guys, very good morning. Let's start the class. I hope you can hear my voice, right? Any questions from the previous session, guys? How we are applying the linear regression? Yes, please mention in the chat box, guys. Yes, guys, you hear me, right? Jyoti, Swati, Kumaresh. Okay, let me share my screen. Okay. Now what I will do is I will create another notebook. We will see about the logistic regression now. Okay. So guys, coming to the logistic regression, like linear regression, the target variable is of continuous values. Okay. The target variables will be of continuous values. You can have any float values. You can consider it like it can be any value. Okay. But coming to this logistic regression, you will be having only two values in the logistic regression. Okay. So like two values in the sense like 1 and 0. Okay. Sorry. 1 or 0. True or false. Okay. Yes or no. Agree. Disagree. Okay. So like that kind of thing. Only two cases you will have. Okay. So in this particular situation, say for example, we'll take a problem statement. The problem statement is like what we call say based on your academics, whether you will be getting a scholarship or not. Okay. So how you will be looking into that particular problem statement based on the academic means you will be having many things in the academics based on your punctuality, or based on your punctuality is a feature, and your studying hours, the marks gained, okay, and the extracurricular activities you are doing, and timely submission of your assignments. Okay, so all these are the variables. So based on these variables, so you want to predict whether that particular candidate is capable to get the scholarship or not. Okay, get the scholarship or not. That's the thing. So in that cases, we will be using the logistic regression. Okay. So this statement clear with you guys? Any kind of doubts in this? Say yes or no. Jyotika, Naveen, Kumaresh, Venkatraj Kumar, Naveen. Okay. What about others? Okay. So that's the thing. So next, uh, this logistic regression is actually the modified version of the linear regression only. Okay. So it's actually the modified version of linear regression. Okay. Say for example, in linear regression, what you will be doing basically, hmm, you are predicting the continuous values, nothing but the float values. You don't know what is the range bound of that thing. Okay. But you are predicting, trying to predict the values here. Okay. Coming to this linear regression, that range bound, you are fixing the range bound to 0 and 1, or between 0 and 1. Okay, the continuous values you are fixing the round between the 0 and 1. Okay, so this particular logistic regression, you are using the probabilistic approach of linear regression. Okay, for example, in the linear regression you are getting some value of 60. Okay, from values of 60.78, some value you have got in the prediction. Okay, so in logistic terms, what is the probability? What is the probability of getting this value? Okay, for the given variables, or x values, what is the probability of getting that? That is the meaning. That's the meaning of this. Okay, so here you can write the statement as P stands for probability of y equal to 1 for the given x. Okay, this sort of formula you have learned in your academics, in your PTSP, probability theory and stochastic process. Okay, so in that you have looked into what is the probability of y coming out to be 1, probability of getting the y value as to be the 1 for the given x values. Okay, so for the x means you can have any number of x columns. X1 you can have, okay, x2 you can have, x3 you can have, x4 you can have, like this. Okay, and here you will be having the y, here you will be having the y. Okay, so this particular thing, okay, what is the probability of y getting as 1, y getting as 1 for the given all x size, or for the given all x variables? Okay, the same thing. What is the probability of getting the value 60 for the given x variables? You are predicting the linear regression only. You are doing the linear form of predictions only, but you are taking the probability of getting this value. What is the probability? Okay, so it's a probabilistic approach here in the logistic regression. So now let's understand how we can derive this particular logistic regression, okay, from linear regression. Okay, so we know the formula for the linear regression: y is equal to b0 plus b1 x1 plus b2 x2 plus b3 x3 plus you can go with so on plus bn xn. Okay, so this is the formula for the linear regression line. Okay, now what is the outcome of this particular thing? What is the outcome? You don't know. Okay, you don't know that the outcome value you don't know. Okay, for example, what I will do is I will consider, let us consider this entire value will be the z. Okay, this is equal to z, capital Z. Okay, so this will, what it will happen, this particular one will come y equal to z. Okay, nothing but I'm substituting, I'm taking this particular value from here to here as z. Okay, now this value z value, whatever the value you calculate here, the entire value, okay, you are calculating some value here, right? That entire value you don't know how much the value will be, so the value always lies between, it always lies between minus infinity to plus infinity. It's true, right? Okay, you don't know, the linear regression value can be negative value as well and it can be the positive value as well. Okay, so it always lies between the minus infinity to the plus infinity. Okay, but our logistic regression values lies between the 0 and 1, so it is not linear. Logistic, in logistic regression the value lies between 0 and 1, but in linear regression the value lies between the minus infinity to infinity. Okay, so what we will do is we will transform this equation so that it can capable to hold the values only between the 0 and 1. Okay, we need to transform it. Okay, so we know that probability always lies between 0 and 1. Okay, always lies between the 0 and 1. Okay, so what we will do, so p, this one belongs to 0 and 1. 0 and 1, we know this. Okay, so now what we will do is, p is nothing but probability here, guys. P is nothing but probability. Okay, what we do is we take the odds ratio. Okay, odds ratio means p divided by 1 minus p. Okay, so p is nothing but the successful events. 1 minus p is nothing but unsuccessful events. Unsuccessful events. Okay, so let me write that one here. Step 1, we will take odds ratio of successful events and unsuccessful events. Like this we will take. Okay, this is the thing. Now see carefully, it is p divided by 1 minus p. P divided by 1 minus p. Okay, so what will happen if p equal to 0? If you substitute 0, what will happen? 0 divided by, what will happen here? 0 divided by 1 minus 0 you will get. Okay, which is 0. Okay, if p value is 1, if you substitute 1, why? Because p value always lies between 0 and 1. Okay, probability. So what I will do here, 1 divided by 1 minus 1 means 1 minus 1 here equal to 0, you will get the infinity. Okay, so what we have done here, we have converted the 0 to infinity. 0 to infinity, sorry, minus infinity to infinity, to 0 to infinity, to 0 to infinity. Okay, that's the thing. Now what we will do here, we will apply step 2, apply log. Apply log. Okay, to the above one. So what will happen here? If you apply log of p divided by 1 minus p. Okay, now you substitute p. If p equal to 0, what will happen again? You will get log of 0. Okay, what is the log 0? What is the value of log 0? Undefined means infinity. So infinity. if p equal to 1, then log of infinity will be again infinity. Okay, so if you want to go with it, you can search it infinity. Log of infinity again infinity. Okay, log of 0 undefined. It's not the real number. Okay, so here what you have done again, from 0 to infinity, you have converted from, we have converted to infinity. So you can consider it as minus infinity to infinity or infinity to infinity, anything. Minus infinity or infinity is one and the same with respect of the sign. So what you have done, you have took the odd ratios of successful and unsuccessful events, p by 1 minus p. The value of this will always lies between these two, 0 and infinity. You applied log here, it converted into the infinity to infinity. Okay, now what we will do is log of p divided by 1 minus p equal to, we have this one, right? Beta naught b0 plus b1 plus b1 b2, sorry, b1 x1 plus b2 x2 plus b3 x3, so on. We equate this. Okay, now we need to find out what is the probability. This is the probability. We need to find out the p. We need to find out the p. So p equal to, like that we need to convert. P equal to, what is the formula? P equal to, so how you will be doing? If log goes here, you will be getting the exponential. Exponential e to the power of b0 plus b1 b2 b3, like that you will be getting. So this entire value is z, right? So what I will do, I will write log of p divided by 1 minus p equal to z. Okay, so if log goes on the right hand side, it will become the exponential. So p divided by 1 minus p equal to e to the power of z. Okay, it's a e to the power of z. Okay, so from this, I think you can calculate this entire thing. Okay, I hope you will be calculating. 1 minus p, you send that way, that side, it will become the multiplication. P is equal to e to the power of e to the power of z into 1 minus p. Like this, you will get, multiply it. Okay, so at the last, if you solve here, you will be getting p is equal to 1 divided by 1 plus e to the power of minus z. This is the thing. Substitute the value of this one. This particular formula is called, substitute the value of z here. Okay, this particular formula is the sigmoid function. Is the sigmoid function. Okay, so this value lies between 0 and 1. Okay, so if you look into the logistic function or sigmoid, if you see the images, Okay, so see 1 by 1 plus e to the power of minus x he has to, we can use any sort of notations x or y or some a or b, it's our wish. Okay, so he has took minus x, we have took minus z, that's it. Okay, 1 by 1 plus e to the power of minus z. So this is how the waveform will look like. Okay, see the values lies between 0 and 1. One minute guys. Okay, the value lies between 0 and 1. Okay, so we have converted that particular minus infinity into infinity predictions of the linear regression to the 0 to 1, lying between the 0 to 1 logistic regression. Okay, sigmoid function. So if you see the curve here, okay, here we are having the 0.5 tendency. So what does this logistic regression will do is it will predict these probability values. Okay, say for example for the given x size, it will go with the 0.2 probability. You have given some input, based on the input it will predict, it has done the prediction 0.2, and for some other input it has given 0.7. Sorry, for some other input it has given 0.7. Okay, so 0.2 means we will take a threshold value here of 0.5. Okay, we will take some threshold value here of 0.5 threshold value. If whatever the predicted probability is above the 0.5, we consider it as 1. Okay, if it is 0.5 threshold value, whatever the predicted value it is, if it is less than 0.5, we will consider it as 0. Okay, so that's the threshold we will be maintaining 0.5. If you want to have the high confidence, okay, you can go with the 0.6, 0.7, like that kind of thing as well. Okay, it's your wish based on the problem statement and based on the accuracy you are getting. Getting guys, any clarification you still needed, any doubts in this? Yeshwant, okay, what about others? Okay, Narsimha, Swati, Venkat, okay. 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 Now what we will do is, as you understood this particular scenario, for this we will be having a different metrics basically. Okay, we will have different metrics. Like accuracy is one of the metric. Okay, so what are the actual predicted and how many are predicted correctly? So based on that, we will be measuring the accuracy. For example, let me show you different images of such things.
ముద్ద
Okay, so see here. This particular boxes are there, right? This is called as a confusion matrix. Confusion matrix. So the name itself is very confusing, right? So even this understanding this particular thing also, it will take some time. So that's why it is called as a confusion matrix. Okay, see here you have got the 0 and 1, which is the predicted. Okay, here on the y-axis you have got the actual 0 and 1. Okay, so for a given data, actually it is 0. Actually it is 0. 0 means negative, 1 means positive. You consider like that. 0 means negative, 1 means positive. Okay, so actually in the actual data, the particular thing is 0. In the actual data, the particular value is 0. And in the predicted one, the value is also 0. The value is also 0. Okay, that means it is predicted, the model has predicted correctly. What it has predicted? It has predicted 0. 0 means negative. So it has correctly predicted as negative. Okay, 0 is predicted as 0. This is 0. Actually, it is 0 and it is predicted as 0. So it is called as true negative. True negative. Okay, and then you are having 1 here. Actually, it is 0. Actually, it is 0. But the model is predicted as 1. The model has predicted as 1. Means it is wrongly predicted. Wrong predicted means false predictions happen. It has predicted falsely as positive FP. Okay. 0 is predicted as 1. Means wrong prediction happened. Okay. Wrong prediction means false prediction. How it has predicted false? It has predicted false as positive T. FP. Okay. Same way it will work here as well. Actual value is 1, but the model is predicted as 0. Okay, 1 is predicted as 0, means false, F. Okay, how it is predicted? It is predicted as 0. 0 means negative. So Fn. That's the meaning of Fn here. Okay, so actually the value is 1, but it has the predicted as 1. So 1 is predicted as 1 means it is a truly prediction, true prediction. It is truly predicted as positive. What it is predicted? Positive, TP. Okay, so this is the thing. So based on this confusion matrix, we will calculate the accuracy. Accuracy is nothing but sum of all the predictions: true positive, true negatives, false negatives. Okay, so sum of correctly predicted divided by total sum of the predictions. Sum of correctly predicted means true negatives and true positives. See, TP plus TN divided by sum of all the predictions. Okay, so that is nothing but the accuracy. We will also have the specificity and sensitivity. Okay, specificity and sensitivity is also there. So it gives us the information that how well the model has to be performed further. How well the model has to be performed further. Okay. So the formula for the specificity and sensitivity is Tn divided by Tn plus Fp. Specificity. True negatives. True negatives divided by true negatives plus false positives. So it will gives us the information that how many are correctly predicted as negatives. Okay. And still how many has to be predicted as truly negative. Sorry. Okay. And the next is the sensitivity. Sensitivity is nothing but it will give the information of the true positives, stating that how many are still present which are to be detected as positives. Okay, which are falsely predicted, and how many still are existing, how the model has to be well performed even further. Okay, so that's what the information it will give you basically. Okay, so we mostly won't go with the specificity and the sensitivity, but it gives us some additional information. With that we can go even further tuning of the model. But when you do that even further proceedings after this, finding out something lacking behind the model, so model may get into the bias state. Okay, the variance will become very less and bias will increases. With that model will be overfit. Model become overfit model. Okay, so we only go with the accuracy. Clear, guys?
అదే పేస్ట్ అతుక్కోదంట లోపల ఇసుకపోతుంది
Any questions? Okay. So have you gone through the Kaggle one Kaggle website portal? Have you verified? Anyone? Have you gone through it? Yes, guys. Have you checked that? Anyone? Have you gone through? You might having the college yesterday, right? Okay. So tomorrow, anyhow, you are having the holiday, right? Go through the Kaggle website. Okay. And understand the linear regression, logistic regression application. They might have coded with a data set. Okay. So with that data set, just understand. Okay. Just understand. So for Kaggle, okay, you can follow this particular one. And then don't go for this types of logistic regression. We won't use that one in the real time. Okay, for multinomial logistic regression, ordinal logistic regression, we go with the neural networks. It give you more accuracy. In real time, we won't go with that. We will see anyhow in the AN and artificial neural networks in the next week. Okay, that neural network concept we will see. Let me share you something. So there are many such kind of things, guys, here. Okay, so you just need to explore all these things. Not all these things. Just keep one thing. One at least try to read one blog from one in a day. In a day. Okay, and try to understand what how they are implementing, what all the technicalities they have used. With that only you can able to cope. You need to make that particular one as an habit. Okay, if you won't do that, then you will be lagging behind. Okay, so I think we stop here. This particular logistic regression. Okay, the implementation part we will see in the next class. Okay, so it will take only one day of understanding the problem statement and applying the logistic regression. So on Thursday we will see how to do this, how to apply the logistic regression, because it becomes a bit kind of lengthy. Okay, and after that we go with the artificial neural networks. We will learn about the neuron, the nodes present in the neuron, how many nodes to use, how many nodes we need to, how many layers we need to create in the neurons. Okay, and then we will understand how to implement the neural networks in the TensorFlow and Keras, using the TensorFlow and Keras. Okay, once it is done, then we can go with the dealing with the images. Okay, some basics of images, and we will see CNN algorithm. Okay, it takes more 3 weeks for completing this uh, internship program. Clear, guys? If you're having any doubts or queries, you can ask here now. Okay. If you're not having any doubts, you can drop, guys.
Hello, sir.
Yes.
Sir, I have a seminar, sir.
Okay.
Okay. But introduction abstract we can manage, sir. But in project of the background details, we can ask, sir.
Project of
Background of the project and details of the project. How can we do it, sir?
which one you are talking about, this internship one, huh?
Yes, sir. Internship, sir. I have first seminar in March 11th, sir.
Okay, you are having some time. March 11, na? When is our March 11?
So we can create a PPTs.
Okay, more 1 week you are having. Okay,
Yes, sir.
I will as since the linear regression is completed, right? You can select any one of the project. One I will give one project on linear regression, one on the logistic.
Oh, yes.
Okay, and one on the neural networks and one on the CNN. 4. Okay, so you
Okay.
can just search in the internet. You will be getting enough resources from the internet for that project. Okay, along with the data set I will give.
Okay, okay.
Okay, so you understand the data set and create an abstract and whatever the thing you want to, you can work on it. It is readily available in the internet. You can just need to figure it out how to search and understanding the data set and the problem statement. Based on that, you can create your abstract. Okay.
Okay.
Okay. By Monday, I will share you that.
Okay, okay. Sir. Thank you, sir.
Okay.
Oh.
Any other questions, guys?